Hello class, we are starting chapter 6 now, which is called Systems of Equations. So in chapter 4 we discussed how to graph a line using slope-intercept form. And chapter 5 we started talking about inequalities, so how to graph a line when we have something that's less than or greater than or anything of that sort. And so chapter 6 is kind of talking about, okay, what if we have more than one line? What if we have two lines? Then what can we say about these two things? So this first section, we're just going to kind of get to the basics of it as usual. So I think this first section will be a little bit easier. It's solving a system by graphing. And the first thing we'll do is determine how many solutions we'll have. This word right here, solutions, can be used in many different ways. We've seen it before where a solution is the same thing as an x-intercept. Today, the solution is where your two lines will intersect. And so that's what we're going to be talking about today, because two lines, they could either cross each other or they could be parallel and never cross each other. And so four vocabulary words that we'll have to be familiar with are the four that are listed right in front of you. The first one is consistent. Consistent means that the lines have at least one point in common, meaning that they at least cross once. Now, how can a line cross multiple times? We'll get to that kind of line in just a sec. An inconsistent number of solutions is that these two lines have no common point. This probably implies that we're dealing with two parallel lines. Because if you think about it, the only time two lines will never have a point in common is if two lines are parallel to one another. Now, numbers 3 and 4 are kind of subcategories to the first one, consistency. So if they have at least one point in common, there are two situations. Number one is an independent consistency, which means that it is a consistent system having exactly one solution, only one solution. They cross at each other just at one time, and they share that just one point. A dependent consistency is a consistent system with an infinite number of solutions. And again, right now that's just kind of in theory and on paper, and you probably don't really know how that can be. But let's get to the first example. The first example reads, use the graph on the right to determine whether each system is consistent or inconsistent, and if it is independent or dependent. Now, independent and dependent means that it has to be consistent. So the first thing we have to do is it consistent or is it inconsistent? Now, the first thing that we see is that here I'll label these line A and line B. So if I look at line A, my y-intercept is at -5. And if I go to my next point, which is right here, I go up 2 to the right 1, so that means my slope is 2. And actually this equation right here is line A. And so line B, if we see our y-intercept is right here, it doesn't look like it's perfect, but it's right here. And then same thing, if we go down to the left one, here's our next point, and the slope again is 2, and this one equation is line B. And so the first question we want to answer is it consistent or is it inconsistent? These two lines are parallel, not just because it looks like it. If you look at the graph, it looks like A and B are parallel to each other, but because the slope is exactly the same, this means it's parallel. And so parallel lines means that we're going to have an inconsistent system. Again, inconsistent system means that there is no solution where they cross each other. Now, because it is inconsistent, there actually is no independent and dependent. So we're actually done here. If you look at example B down here, y equals 2x minus 5, that's again line A. And then you'll notice that line B right now is not, y is not by itself. So you have to go ahead and solve for y by subtracting 4 and then dividing by -2. Now, you'll notice that when we solve for y, we actually end up with y equals 2x minus 5. And y equals 2x minus 5 is the same exact equation as we have as the first one. Now, you'll notice that they have the same slope, so our first indication is that they're parallel to each other. But since they're the same exact equation, that means they're the same exact line. For example, if you have, so if you look at the graph on the right, there's another line on top of line A. And so where does the green line and the line A, where do they meet? They meet at every single point. And that's why this is considered a consistent system. And then under this category of consistent system, there is a subcategory of, is it independent or dependent? Independent means, again, are they just crisscrossing at just one point, or are there an infinite amount of solutions? This, since one line lies on top of the other line, is a dependent consistency. So if you kind of get that, we're going to move to a table that's underneath on your in your notes, and we're just going to kind of briefly summarize what that says. So this table just kind of briefly summarizes what we've been talking about. So if there is only one solution where they just crisscross each other, and here's a sample graph, the red and the blue graph, then that means they are consistent, they do have a solution, and it's an independent. So they just meet at one point, and that point is right here. This is my solution. If there are an infinite number of solutions, you recognize that there's only a blue line. But there are really two lines. There's a blue line, and then there's a line underneath that it's on top of. So these two lines are literally the same thing, and so this is consistent because it does have a solution, and it has many solutions, and it is a dependent, so consistent and dependent because it has an infinite number of solutions. And then the last case is if there is no solution, meaning they don't cross each other, or if they're parallel lines, then they are inconsistent, meaning that they never cross one another. So these are honestly just different ways of talking about parallel lines and lines that are intersecting one another. So now the next thing we'll do is we'll have you actually graph, and this is again from chapter 4 using slope-intercept form. So here I'll label it as line A, and then I'll label the second one as line B. Maybe line B I will make a different color so that we can we'll be able to differentiate the two. Line A is already in slope-intercept form, so there's nothing that we need to do. The slope is 1/3 and the intercept is -3. So if you want, maybe on the graph to the right, you can go ahead and graph those points. There are my 2 points. My y-intercept is at -3 and the slope is up 1 to the right 3, and I'm just going to draw a line that looks like that. So here is line A. And you'll notice in line B that y is not by itself in the equation, so we'll have to subtract x and then make a dividing, have to divide both sides. So after we solve it, you'll see that y by itself is equal to 1/3 x plus 1. Now when we compare that to line A, we notice right away they have the same slope, which means they're at least parallel. Now their y-intercepts are different, so they're going to be parallel. So even without graphing, you can already make an assumption of what's going to happen. There's not going to be a solution here, but let's graph it anyway. Let's look for our y-intercept at +1, and then move up 1 to the right 3, and there's our other point, and we will connect these points with a straight line. So by looking at the graph, we'll notice that we have 2 parallel lines, and we can make that for certain by looking at the slope. We have 1/3 and different y-intercepts. Therefore, this is going to have no solution, which means it is inconsistent. Okay, and then if it is inconsistent, that means it can be neither independent or dependent. So if you have any questions, just write down the questions and then maybe bring them back tomorrow in class, but let's move on to the next part of the notes. So pretty much the rest of the note is just 3 examples of graphing and being able to say how many solutions are there. Are there 0 solutions, 1 solution, and infinite solutions? Now be careful because the directions here say that if it has 1 solution, then they actually want you to name the ordered pair. So if they cross just at 1 point, they want you to actually name it. So this first one will have line A and line B, and why don't you pause and take a few minutes to get y by itself for both of them. Alright, so I have my equation for line A, which is y is equal to x minus 2, and I have my equation for line B, which is y is equal to negative 2/3 x plus 1. Now they have different slopes, different y-intercepts, so most likely these two guys are going to intersect. Now let's plot line A first. My y-intercept is at negative 2, and I have a slope of 1, which is just 1 over 1, so I'm going to go up 1 to the right 1, up 1 to the right 1. And then I'm going to grab my line tool, purple line tool, and try my best to make a straight line here. And there's line A. And then the same thing if we do line B, y is equal to negative 2/3 x plus 1. My y-intercept will be at 1, a positive 1, and my slope will be down 2 to the right 3. Okay, class, confession time. I made a mistake on line B. On line B, while doing the work, I noticed that I accidentally, my y-intercept is actually wrong. It should be 3. Okay, so hopefully some of you guys caught that. My y-intercept is at positive 3 now, and I'm going down 2 to the right 3, and you'll notice that it's actually on the purple line, so that's a good sign. So that green point on that purple line is where they intersect, but let's make the line anyway. So we have 2 lines here, line A and line B. Again, I apologize for that mistake that I made. My solution is right here, whatever that point is. And so since there is just 1 solution, then they want me to find the coordinate point. My coordinate point is 3, 1. There is my solution to this system of equations. So why don't you move on to the next example, try that one on your own, and then I'll show the work first, give a brief explanation, and then show the lines again. So I have y is equal to 2x minus 3, and 6x plus 3y is equal to negative 9. Y is equal to 2x minus 3. Y is already by itself, so I'm just going to label this as line A. And then line B, I'm going to solve for y by itself. So take a minute to do that. So once you got line B, and I did double check just to make sure that I got it right this time, my line B is y is equal to negative 2x minus 3. Now, you'll notice that the slopes are different. They look the same, but they're different. Positive 2x and negative 2x. So the slope is different, but this time the y-intercept is the same. So if you make an observation, you can kind of already tell which point is going to be shared between these 2 lines. But if you can't really tell, I would suggest, why don't you take a minute, pause, and graph these 2 lines, A and B. After you've graphed it, we get line A and line B, in orange and purple, crossing at what you'll notice is the y-intercept. So that's why I said if you really make this connection from the equation, here is my solution already. So I guess we didn't really need to graph it to find the solution. So 0, negative 3 is my final answer here, and that is where they meet. And the last one, I'm going to have you do the whole thing on your own. So why don't you take a moment to pause, do the whole thing on your own, check the graph and all the equations and stuff at the very end, and just check your answer. So if you solve for y correctly for both cases, you should end up with 2 lines that are parallel to one another. They have the same exact slope, but they have different y-intercepts this time. And on the graph here, we have a blue line and a red line, indicating line A and line B, and they are parallel. Therefore, there is no solution which means this is an inconsistent, I feel like I'm going to run out of room, inconsistent system. There we go, inconsistent system. So that's kind of the lesson today. Graphing two lines and saying pretty much, do they meet each other? If they meet, then that meeting point is a solution. If they don't meet, then there is no solution. If they meet on top of one another, then that means it is an infinite number of solutions, and you just have to remember the vocabulary words. So tomorrow in class, why don't you come with questions? If you have any, I'll briefly sum this up, and then I'll give you the homework assignment.